Is it recording? No.
Yeah.
Oh, it is. Okay. So 6-63, here's a sequence. It says 2, 10, 50, 250.
I think it may be times 5, but I'm not absolutely sure.
Yeah, I think it looks like it's times 5.
Yeah. Yeah.
Because if it keeps doing it that many times, it is. If it just does it once, and then it doesn't do it on the next one, then you got a problem, but you're right.
It's
geometric.
That's what I got.
It's geometric. Good. She knows that when it multiplies, it's called geometric. So that's what the question was asking us. And then
Wouldn't it be like the curved one,
yes.
parabola. Exponential?
Exponential. Yeah. Parabola looks like an exponential in that it is curvy, not linear, but it's not the same thing. So
wouldn't this one go down and then back up? Or up and then back down eventually?
This one, it just probably has a starting point right here, you know, at the 0 term at 2/5, and then it probably just kind of goes up. Pretty steeply, it looks like it goes up. It just looks something like that. You know what I mean? Okay, that was letter B, and then C, write an explicit equation. Hey, so we do have to, an explicit equation.
I forgot the difference between explicit and
recursive. You don't want to write a recursive. The recursive one would just be that it's multiplying by 5. So it'd be like a of n plus 1 equals 5 a of n or something. But this one, remember if it's, oh wait, this one, it's not going to be like y equals mx plus b, it's going to be exponential. Does anyone remember? Like, you know how for a line we have y equals mx plus b?
Oh, yeah, this is going to be t sub n, yeah.
Yeah, so we'll use t sub n, t of n equals, but if it goes like this, a b to the x. Does that look familiar to anybody as the exponential?
Yes, on the calculators.
Yeah, on the calculators. Also, we worked a little bit with some exponentials. So we're kind of supposed to know, I think this showed up in a math notes box, that the a is the initial value, or the starting point, and the b is the multiplier. So we need to figure out what the starting point of this sequence is.
Would that be the 0?
Yes, that would be the
0. Because it's times 5, times 44.
No, she means, will it be the 0 term? So that's the first term, second term, third term. So I need the term that...
The 0 term would be... Wouldn't it be 0.4?
It'd be, yes, it'd be 2/5, or 0.4 is the same as 2/5. Yeah, we can use 0.4 instead of 2/5. So how did you get that, Sandy?
2 divided by 5.
Yes, because if you're going backwards, you're dividing. And when you go forward, you multiply. When you go backwards, you'd have to divide because they're inverses of each other. So we know that the starting point is 0.4. And then what's the multiplier? Well, we said it was 5, right? And then just, instead of an x right here, I'm going to put in n. Okay, because that's kind of how we do it when it's this one. And this one's like a function, and this one is, well, it's still a function, but this one is a sequence. Okay, and let me check that and make sure that's correct. They use 2/5, but it's the same thing as 0.4. Good job. Okay, so that was done. Are we out of time? I hear the other class is getting.
Yeah.